So in the last video, we basically talked about what composition of functions were, and I sort of gave an example. Let's actually do some calculations for composition of functions. So a composition of function is sort of, it's defined, imagine we have two functions. We have f of x and we have another function, g of x. All right? So if I want to say that f of x is composed of g of x, in other words, the input, what f does, it takes g of x as the input. We write it like this. So in other words, let's say if I wanted to say this, right, where I'm taking g of x as the input for f, the way we write it is f of g of x, right? So these two mean the same thing, right? So say for example, if I had written g of f of x, like the other way around, where g is taking as its input f of x. So what you would do is you do g, you put a big bracket around, and what are you taking as input? You're taking f of x, right? So it's very important that the notation is this open circle over here, and the second function that you see here is the input, and the first function that you see here is the output. So you're doing f, so in this case, for example, you're doing f of g of x, but in this case it's the other way around, where f now becomes the input for g. All right, so let's actually do an example of this and see how that works. So let's say f of x, so make sure you're writing this down by the way, f of x is equal to x plus 1 square rooted, and g of x is equal to x squared, okay? So let's do the first thing where, say I want to find out f of g of x, okay? So if I'm doing f of g of x, what this means is first I take f, and as my input, I'm going to put g of x. Now, what is g of x? G of x, as we see right here, is x squared. So what that means is f of x squared. Okay. Now, what do I do next? What this means is instead of x over here, we're going to replace it. This x will now be replaced by whatever the argument is over here. All right. So the argument in this case is x squared. So we're going to replace that x with x squared. So basically, this becomes the square root, and maybe I'll just write this in green, and instead of x, I'm going to replace it with the argument over here, which is x squared, but I'm going to keep everything else the same, right? All I have to do is just switch the argument, or replace the argument with, for x, or replace x for the argument, and then plus 1, right? So this is it, and this can't be simplified any further, so the answer to f of g of x is simply x squared plus 1, x squared plus 1 square rooted. All right, and that's our solution. Now let's do the opposite. Let's try to find what g of f of x is, okay? So let's do that here. So g of f of x, right? So what that means, as we said before, is that it means it's g, and in its argument, I'm going to put f of x. In other words, my input is now f of x. So let's look at what f of x is. So g of, we said, f of x is the square root of x plus 1. So we're going to put x plus 1 in the square root. And what I'm going to do, just to show you over here, is that we said that g of x is equal to x squared. So what this means, like before, is that the argument now of g is the square root of x plus 1. So we take this and we replace it, we replace x with it, all right? So, or replace it for x. So what that means is, let me just go here. What that means is this is equal to, right? This is supposed to be x squared, but instead of x, I'm going to write, I'm going to put in the argument, which was the square root of x plus 1. And since I'm basically squaring the square root of x plus 1, this becomes x plus 1. All right? And that is how we do g of f. So keep in mind that when you're doing the composition of functions, you know, the second function that you see becomes the argument, all right? And then replace the argument with, so replace x with whatever the argument is. So same thing over here when we did g of f of x. F of x is square root of x plus 1, and we said that g of x is simply x squared. So I'm going to replace x with the square root of x plus 1. I did that over here. This, in effect, is like that x that whole thing, and I'm replacing with square root of x plus 1. And so since I'm squaring that and this square root, they both sort of cancel out. All right, and what am I left with is x plus 1. Okay, let's do one more example. Let me just go to the next page. So let's just say, for example, you want to find a specific value. Okay, so let's just say f of x is equal to x plus 1, and g of x is equal to, say, 2 times the square root of x. Yeah, so let's just say, for example, I want to find what is f of g of 4. Okay, so instead of x, I want a specific value. I don't want a function anymore. I want a specific value. So what that means, so the best way to do this is first find what is f of g of x. Okay, so let's find this, and then what we can do later is just simply plug that 4 in and we'll get our answer. So what this means is f of g of x, okay? G of x, as we know, is 2 root x, so f of 2 root x, okay? And what we're going to do is we're going to replace this x over here with 2 root x, because this is the argument, and we're replacing x with the argument over there. So what that becomes is 2 root of x plus 1, because remember, this is f of x, and we're simply replacing this x with the argument over here. So this becomes 2 root of x plus 1. Now, what we want to do is find f of g of 4. Okay, we've already found f of g of x, so all we have to do is now replace, if we replace this x with 4, we can replace that with a 4 and we can figure out our answer. So, f of g of 4 is equal to 2 root of 4 plus 1, and that's 2 times 2 plus 1, which is equal to 5. Okay, so f of g of 4 in this case is 5. All right, I hope that makes sense, and in our next video we're going to go over inverse functions, and I'll explain what that is as well, but make sure you understand this example because this is extremely important.